All right, section 1, counting outcomes. So here's a few examples of tree diagrams. We're going to use it to find all the possible outcomes for a situation. So for example, if TA plays Biddeford in the best of 2 of 3 series, what are the possible outcomes for TA? So the first thing that we do is we want to say that we're either going to win or we're going to lose the first game. From there, during our second game, we also could either win or we could lose. Then if we just kind of go through the combinations for the third game, we could either win or lose after winning the first 2, or we could win, lose, and then win or lose the next one. Now, when we go through, we just want to figure out exactly all of our combinations. We just look at the end. So we're going to say we could win all 3. We can win the first 2 and lose the last one. We could win, lose, win, or win, lose, lose. So we have 4 outcomes if we win the first game. So if we lose the first game, your possible outcomes are winning or losing. Then, if we lose the first game, win the second game, we could either win or lose the third. Then, if we lose and then we lose again, we still could have the options of winning or losing the last of the game of the series. So in the end, you have another 4 outcomes. So you could lose, win, 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 lose, lose, win, or lose. Oops, I wrote that wrong. Hold on. I'm back here. We could lose, win, lose, 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 win, or lose, lose, lose. So in the end, we have 3 different games. We could win or lose, so we have 2 in each category, so 8 different outcomes. So if you move on to the next example, we're saying that what happens if we flip a coin first. We could either have heads or tails. And then we rolled a 6-sided die. So how many different sides does a 6-sided die have? Well, 6. So you could have 1, 2, 3, 4, 5, 6. And then same thing if we flipped it tails first and then rolled. You would have your 6 combinations. So in the end, you have 12 different possible outcomes. Because you could have head 1, heads roll a 2, H3, H4, sorry about the bell, H6, or T1, T2, T3, T4, T5, or T6. All right, last few examples. All right, so last 2 examples. So fundamental counting principle. What it does is it's an easier way of completing a tree diagram to figure out how many outcomes you would have without doing all that work. So for example, if you had a lunch special at Uptown Deli, you could take the amount of options in each of your categories and multiply them. So you have 10 different sandwiches, 12 different sides, and 7 beverages. And what you do is you multiply those 3 numbers, the amount in each category, to give you the number of options. So instead of doing like 10 different sandwiches and 12 different sides and so forth, this is just an easier way of completing this particular problem. In example 4, we're talking about a factorial, and all that is the exclamation symbol. And what you do is, if we had 4 explanation, it doesn't mean that you yell 4, it means that you take and expand it. So you do 1, 2, 3, 4. So you always start with 1 and go up to the number that they give you, and then multiply those numbers. So in this case, 4 factorial is 24. If we look at 6, you just do 1 times 2 times 3 times 4 times 5 times 6. Multiply all those together, and you get 720. And we'll use this in the next section.